In this video, I'm going to show you how to use Microsoft Excel 2010 to conduct a one-way analysis of variance. And before we begin, I want to make sure everybody knows where to find the data analysis tool pack. I already have that installed on my computer, and you actually find it under this data tab right here. So when you click on the data tab, it would be over here on the far right if you already have it installed, and that's where the data analysis tool pack is. If you don't have it installed, all you're going to do is choose File, choose Options, and then we're going to select Add-ins. And when this comes up, you can see it's already an active application in my add-ins, the analysis tool pack, but I'll choose something else so you can see the dialog box that comes up. So I'm going to choose this analysis tool pack -VBA, and the logical thing would be to go ahead and click OK, but that actually closes the screen. It doesn't get you there. So what we need to do is we need to click Go, because that's going to bring up the menu with the Excel add-ins in it. And then we're going to choose the analysis tool pack, and you can see I already have that checked. If you do not have it checked, you'll need to check that and then click OK. And I'll just hit cancel since I already have that installed. Once you have that installed, you can use that to conduct the one-way analysis of variance. And what we want to do is we want to choose data analysis, and then I'm going to scroll up to the top. So we're going to use a single factor analysis of variance, and then I'll say OK. And when this comes up, it's asking me for the input range. So check this little box right here, click on this little box right here, and then you're going to select all the data, including any headings that you have, and I'll show you why in just a little bit. But you can see I have everything selected. You can either click this button on the right of the dialog box to get back in there, or you can hit enter, and that'll bring you back in as well. And notice the data is grouped by columns, by Tom's data, John's, Lisa's, April's, so on and so forth. So we want to make sure we have the appropriate grouping down. We have labels in the first row, and we want to identify that so it recognizes that there's labels. And then we get to select our level of significance, or our alpha value. And depending on the problem that you have, you'll change that to whatever is appropriate. Now, I like to insert my analysis of variance table into the Excel spreadsheet because it's a little bit easier rather than having it on a new worksheet, so I can look at the data and look at the summary information. So what I do is I choose this radio button right here that says output range, and then I'll click the button to select my output range, and I'm just going to select an area right over here, somewhere where I can see everything. Then I'll go ahead and I'll hit enter this time. So once I have all that information populated, I can go ahead and click OK, and that'll spit out the results. And you can see right here we have a single factor analysis of variance. It gives us our summary by each of the individuals, so it gives us the count, or the number of data points each one had, the sum of all those data points, the average, the variance. So it gives us a lot of information that we can look at and summarizes that for us. But more importantly, we have our analysis of variance table right below, which is this right here. And one thing I want to remind you of, when we talk about it in class, we talk about the between groups. Those are actually called the treatments, is how we refer to those. So the treatments would be Tom is one treatment, John is another, Lisa is another, and so on and so forth. So those are the treatments. And within groups, that source of variation is the error. That's within this group, but the error within that group. All right, so that's our error, that's our treatment for our sum of squares. Our degrees of freedom are next. Our mean square error is next. And then this F value right here, this is the calculated value of F. And we get that by dividing this mean square treatment by the mean square error of 7.71. And that'll give us that value. So that's a calculated value. And then the value that we get from the back of the book, or the book value, is this, the critical value. This is the value that we would look up based on the degrees of freedom in the numerator and the degrees of freedom in the denominator, along with whatever alpha value we choose. Now from there we can use that to finish up this hypothesis test on the means right there and use that to make our decision.